All right, friends, this next one is an equation that involves a compound angle. Those parentheses in there, that's pretty much a compound kind of angle thing. And so, again, we're going to isolate the cotangent by subtracting square root of 3 from both sides. And so we have the cotangent of our angle, which is x minus pi over 2, is going to be equal to a negative square root of 3. Once again, the next thing that we're going to do is take the inverse cotangent of both sides. Okay? Now, I'm just going to leave this as x minus pi over 2. That is all we have left on the left-hand side of the equation. On the right-hand side, we have the inverse cotangent of negative square root of 3. Okay? This is the point where we go ahead and break this apart into the two quadrants where the cotangent is going to be a negative square root of 3. Cotangent is negative in quadrant 2 and in quadrant 4. Okay? So we are going to have what we have on the left-hand side, x minus pi over 2 equals, and then here we're going to say what angle has a cotangent of negative square root of 3. And then quadrant 4, we're going to have x minus pi over 2 equals, and there you'll give the angle that has a cotangent value of negative square root of 3. Okay? Let's think about this. In quadrant 2, you need to give me that angle that has a cotangent value of negative square root of 3. It's going to be the same angle that has a tangent value of negative square root of 3's reciprocal. Okay? Now, if you do the little hand trick where you flip your hand over, then what angle that is it has like a 30-degree reference angle. 30 degrees is the reference angle, but pi over 6 in radians, and so this angle in quadrant 2 is actually 5 pi over 6, and we better go plus 2 in pi, okay? And then in quadrant 4, it's still going to have a reference angle of pi over 6, but this angle is 11 pi over 6 in quadrant 4, okay? So 11 pi over 6 plus 2 in pi, okay? Now, at this point, I think probably what we want to do, like we did in the last example, is we'll want to say, well, I can describe this because it's cotangent, or you could do this on tangent as well, because these angles are just 180 degrees apart from one another. We could say x minus pi over 2 equals, let's just do this one, 5 pi over 6. But we're going to just say plus n pi, right? And that plus 1 n pi takes care of also this angle down here in quadrant 4. Okay? So now, the last thing we're going to do is add pi over 2 to both sides. Well, maybe not the last thing, but the next thing we're going to do is solve for x. Just doing some algebra like we did on the last two examples. So I am going to add pi over 2. Where should I squeeze that in here? Let me squeeze it in right here. I'm adding pi over 2 right in there. Okay? So what we end up with is x is equal to, and again, I've got to build up my fractions. So there's 3 pi over 6 plus 5 pi over 6 gives us, that'd just be 8 pi over 6, wouldn't it? Okay, 3 pi over 6 plus 5 pi over 6 is 8 pi over 6, and then bring down plus n pi. Then you would want to reduce that, okay? That's going to be 4 pi over 3 plus n pi. And really, there's nothing wrong with that, but that's probably not the answer they want you to give. Because let's, for example, get the smallest angle we possibly can as the leading term, okay? And we can get a smaller angle that would satisfy this relationship here if n is equal to a -1, 4 pi over 3. Let me write this. 4 pi over 3 plus a -1 pi is the same thing as 4 pi over, I'm having to scroll a bunch. Okay, 4 pi over 3 minus pi. Another way to write pi with a common denominator is 3 pi over 3. And so this is just positive 1 pi over 3. So even though this and this describe the same set of angles, they're probably going to want you to give this one because it's the smallest positive angle as the lead term. Okay? Okay, so that's what we're going to use for the general solution on part A. So on part A, it's the set of all values of x such that x is equal to pi over 3 plus n pi. That's our answer for the general solution. And then we're going to use that formula to get some solutions on the given interval. Okay? Now, since we went ahead and backed this up to where we had the smallest positive angle, we can start with n equals 0. If you would have forgot to do that, and you would have used this form of it, you would have had to let n be equal to -1 to get an angle that satisfies that in between 0 and 2 pi. But since we went ahead and did that work a minute ago, we can start with n equals 0. Now, when n is equal to 0, our formula above says x is equal to pi over 3 plus 0, or 0 pi. So we're going to get x is equal to pi over 3. And pi over 3 is in this interval. We need it. Now let's let n equal 1. If n is equal to 1, we have x is equal to pi over 3 plus 1 pi. We need to get a common denominator, so I'm going to rewrite that 1 pi as 3 pi over 3. So what we end up with there is x is equal to, right, 1 pi over 3 plus 3 pi over 3 is 4 pi over 3. There that number is again. Okay? Now let's keep going until we get past the 2 pi. So n is equal to 2. Using our formula above, we're going to have x is equal to pi over 3 plus 2 pi. And when you take pi over 3 plus 2 pi, you get something bigger than 2 pi. So that's going to be, yeah, a solution, but not in the interval that they want us to give. We only have those two answers of pi over 3 and 4 pi over 3 for the solutions that just lie in this indicated interval. Those are our only answers there.